All right, check this out. Let's say I'm standing on this line right here, and I want to spin around in a circle. So I start spinning. I go 90 degrees. I keep spinning. 180 degrees. 270 degrees. Keep on spinning, and I get to a full 360. But I'm not done yet. I want to keep spinning. So I keep going. I keep going. I keep going. I keep going, and I stop right here on the 90-degree line. Now, my question for you is, did I spin 90 degrees or did I spin 360 degrees plus 90 degrees, which would be 450 degrees? Which of these do you think, 90 or 450 degrees? Well, I'm in the same spot here of the 90 degrees, but I have to be more than 360 because I kept spinning, right? Well, the answer is kind of ambiguous because technically I did go 450 degrees. I went 360 and I kept going 90 more, but I'm in the same spot as the 90 degree line. So this is what's known as coterminal angles. While technically coterminal angles have a different degree measure, we can treat them exactly the same in mathematics. This is all reminding me of when I was a little kid. I used to love riding the merry-go-round, and as I spun around and around on the merry-go-round, I would always call out the radian measure as I continued on in a circle. So I'd start off slowly, I'd get to pi over 2, continue to pi, 3 pi over 2, 2 pi, pick up speed a little, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, going, 9 pi over 2, 5 pi, 11 pi over 2, 6 pi, and I just keep going and going and going. Those were good times. So fun, so fun. Anyhow, you can see on this picture all the different coterminal angles you have. Here at pi over 2, this is the same spot as 5 pi over 2, 9 pi over 2. Over here at pi, this is the same as 3 pi and 5 pi. Over here, we've got 2 pi, 4 pi, and 6 pi. And you can keep going and going and going, keep adding circles and circles and circles. Go ahead and transition back to degrees, but instead of going with the crowd, what if we tried something else? What if we reversed our direction and went backwards once we get to here? Now, have we gone 270 degrees? What do you think? We know 270 degrees would be all the way around this way, but what if we went backwards to here? We're in the same spot as 270, but how we're going to reference this going backwards is actually negative 90 degrees. So whenever you go the opposite direction, you're just going to be subtracting. So we get to here. If we continue going up over to here, this would be negative 180. Continuing up here, this would be negative 270. And then finally back to where we started, negative 360. So coterminal angles can also be negative. Let's do a couple examples. Here we want to find two positive angles and two negative angles that are coterminal with the given angle. Here we have an angle of 120 degrees, illustrated right here on our graph. This is 120 degrees. So if I wanted to find a coterminal angle, it's going to have to be on this same line here. Well, I know if I go a full circle all the way around, I'm going to end up right where I started. And to do that, I'm just going to have to add 360. So if I go ahead and add 360 to my 120, that's going to give me a coterminal angle of 480. Okay, we need another positive one, so why not just go ahead and make another circle all the way around? Boom, that's another plus 360, so I can add another 360 here, and that's going to leave me with 840. So there's my two positive coterminal angles. If we wanted to find a third coterminal, we could always add another 360, but I notice in our instructions here we want to find two negative coterminal angles. So instead of going in a circle that way, this time I'm going to go reverse a whole circle this way. Instead of adding 360, I'm going to subtract 360. So if I subtract 360 from my 120, I'm going to get a negative 240. I can do the same process, go around one more time. That's going to subtract another 360. leaving me with negative 600. So we found our two positive coterminal angles and our two negative coterminal angles. And all of these, even though they're different degree measures, all will lie on the same spot on the circle. So as a shortcut, if you ever want to find coterminal angles, if you're dealing with degrees, you always want to add or subtract 360 because 360 degrees makes one circle. If you're ever doing radians, now we didn't do an example in radians, but it's the same process. You're just going to add or subtract 2 pi because 2 pi is a circle. Now with dealing in radians, you're often going to end up with fractions. So remember, whenever you add 2 pi to a fraction, you're going to have to get common denominators.